College of Engineering and Technology, Department of EEE. The subject code name is 20E601, Power System Operation and Control, Unit 5, Computer Control of Power Systems. So these are all the topics we are going to cover this unit. So computer control of power system, the major outline, introduction, model of energy management system functions and SCADA application, time decomposition of the power system operation, open distributed system and energy management system, and object oriented programming systems. First one, energy management system. Enhance the scope of SCADA by providing the power application software to assist the operator in monitoring and control of electrical network. It consists of three important phases. First one, gathering information. Second one, decision making. Third one, action by transmitting control order. Control order either directly or indirectly. Next one, model of energy management system, network analysis. Second one, generation, scheduling and control. So two things, it will be collect the database, and then database is given to SCADA systems. Next one, real-time modeling of the system, network configuration analysis, observability analysis, state estimation and data processing, network application and functions. So energy management application and SCADA functions. First one, real-time function, topology analysis, state estimation, network security analysis, generation dispatch. And then second one, extended real-time functions, short-term load forecast, operator load flow, and short circuit calculations. Here power system, this power system, it will be connected for the automatic control system. Automatic control system is signal is given for power system operation and control. So next one, planning and training. So all those things, it will be connected for this bidirectional, the signal and power is given and also power is connected. And the power system operation control, it will be monitoring for real-time function with this computer aided operators decision making for using SCADA systems. This system power system generation and distribution control center, online closed loop control, so online open loop control. This is online and offline task in energy management systems. So the functions of energy management system can be classified in two categories: primary analysis and then secondary analysis. Primary analysis programs for message, control of information, recording of status, information processing for telecommand and control. Secondary analysis, state estimation, optimal power flow, network security, load prediction. This is a time decomposition of power system operation, pre-dispatch, dispatch, and then post-dispatch, network training simulator. So all those things we have to connected for this system in bidirectional connections. So the network connected for each line for this bidirectional. So the functions of pre-dispatch in energy management system. So these are all the systems we have to connected for this one of the block diagram. The system will be operated in step by step. So the next one, hierarchical control in energy management system, load frequency control, economic dispatch, power exchange with interconnected utilities, unit commitment, and then maintenance scheduling. Then on load and off line functions, telemeter inputs and the improved state estimation, online power flow, automatic generation control, contingency evaluation, reserve determination online, base data, and then load forecasting, fuel management, maintenance scheduling, load flow, optimal load flow, and then offline. Application of program in energy control center. Power system, state estimation, transmission monitoring, contingency selection, online load flow, corrective strategies, and operator. This selection signal is given for load forecasting and external equivalence. The power generation is megawatt hour monitoring for online automatic generation control. Operating states of power system. So first one normal, then second one restorative, third one alert system, and then in extremes and emergency. So it's the operating state of power system. So operating system for equality constraint and inequality constraint. Normal means equality, and then inequality constraint means indicating for I. Alert system is equality constraint and then inequality constraints. Emergency, in extremes, and restoratives. So in extremes it will be opposite of equivalent constraint. Restorative means opposite of equality constraints. Different types of control action. So the operating state of control actions, preventive, and then preventive corrections, and then corrective maintenance. The computer aided for decision making in control centers. So next one, application for energy management systems and energy trading systems. So energy management system EMS and the energy trading system ETS, it will be connected to interfacing devices of computer control systems. Next one, block diagram of an integrated EMS, database, SCADA system, test jack, and a central blackboard, HME, and the power system simulator, numerical processes, and symbolic processes. The closed system versus open system. Closed system for software restricted to run on a property platform. Data sharing with other computers extremely difficult. Next one, open system software. No longer relied on the single vendor to supply all the hardware and the software for the EMS. Select the each individual subsystem within energy management system from different vendors. Impact of open system in EMS. Purchase the hardware and software requirement for the sufficient capacity. Incrementally upgrade the system. Next one, SCADA system, that means supervisory control and data acquisitions. So electric power generation, transmission and distribution, manufacturing, mass transient, water and sewage. So these are all the places we are using for this SCADA systems. So buildings, facilities and environmental. Facility managers uses SCADA to control HVAC refrigeration units, lighting and the entry systems. Traffic signals regulate the traffic lights, control the traffic flow and detect out of order signals. So these are all the different places we are using for this SCADA system, and it will be easily monitoring for master unit and the human computer interfaces can getting for this different data in various places. So SCADA system perform the four functions: data acquisition, network data communication, data presentation, and control signals. Data communication using for collecting the data from IP address or Ethernet protocols. Security is using for local area network and wireless area network. Encoder using for protocol format. Sensor using for remote telemetry unit, and encoders and receive command from protocol from the master transmit electrical signal. These are the data communications: trending, security, encoder, sensor, and remote terminal units. That means RTU. So communicate with all on-site equipments. So the construction is rigid construction, sufficient capacities, and a secure redundant power supply for 24 hours by week. Selection of SCADA in masters. The SCADA master should display information in the most useful way to human operates and intelligently. Regulate managed systems. Have flexible programmable soft control to respond to sensor inputs. Automate reaches or emails are directly to repair technician and provide detailed information display in the format of a complete description of activities happening, how to manage it. State estimation. The state estimation is the process of assigning a value to an unknown system state variable based on measurement from the system according to some criteria. Aim to obtain the best possible values. Need for state estimation to smooth out small random errors in meters reading, detect and identify gross measurement errors. Next one, errors. In accurate transducer calibration, the effect of analog to digital conversion, noise in communication channel, unbalanced phases. Measurement scheme. So these are all the phase measurement scheme using for these state diagrams. That means the error. Next one, state estimation. Weighted least square criterion, maximum likelihood criterion, minimum variance criterions. Types. And then this block diagram using for weighted least square estimation. Then treatment for bad data or error identification, human data handling error, measurement error due to faulty devices. These are all the identification for bad measurement with the deterministic state estimations. The next one, detection of bad measurement with the parabolic state estimations. Comparison between load flow study and state estimation. Load flow and state estimations.